there is a layer of reality so strange, so counterintuitive, that Albert Einstein famously called it spooky action at a distance. It is a phenomenon that violates our most basic understanding of space and time, a ghostly connection that seems to bind particles together no matter how much empty darkness separates them. This is the world of quantum entanglement, and in that spooky connection we may find the keys to humanity's future in the cosmos, not as a way to break the laws of physics, but as a way to master them. To understand entanglement, imagine two cosmic twin particles linked at their creation. They are sent flying in opposite directions at nearly the speed of light. Now, a fundamental property of these particles, let's call it their spin, is in an undecided state. But the moment you measure the spin of one particle and find it is up, you know with absolute certainty that its twin, even if it's now light years away on the other side of the galaxy, has instantly assumed the opposite state of down. This change is instantaneous. It is not a signal that travels. It is a shared reality that resolves itself across the entire universe in a single moment. For decades, this incredible fact has fueled one of science fiction's greatest dreams: faster-than-light communication. If the connection is instant, can't we use it to send messages across the stars, to have a real-time conversation with a probe at Proxima Centauri? For a long time, the answer was a disappointing no. Physicists established what is known as the no communication theorem. You can't control the outcome of your measurement. The result is always random. You can't force your particle to be spin up to send a 1 and spin down to send a 0. You can only measure a random outcome and then call your friend on a regular light-speed phone to tell them what you got so they can confirm their particle was the opposite. But that initial disappointment misses the true potential of entanglement for interstellar communication. The goal isn't speed, but security. Imagine an interstellar probe arriving at a new world. It needs to send back its precious data, a journey that will take years. How can it ensure that data is not intercepted and read by a rival, or worse, corrupted by one? It can use entanglement to create a perfectly secure quantum key. We could generate a pair of entangled particles, keep one here on Earth and send the other with the probe. When the probe is ready to transmit, it measures its stream of particles, creating a random sequence of 1s and 0s. That sequence becomes the un-hackable key to encrypt its message. Here's the magic. If an eavesdropper tries to intercept and measure that key, the very act of looking at it would instantly break the entanglement, and both we and the probe would know the channel was compromised. It is a cosmic tripwire. The probe's message would still travel at the speed of light. But with this quantum key, it would be an unbreakable whisper across the void. So entanglement might not give us instant conversations, but it gives us private ones. It's the foundation for a secure galactic internet. But what about the other great challenge of interstellar travel? Power. A ship traveling for centuries between stars can't rely on solar panels. Its batteries would eventually die. How does it stay alive in the cold and the dark? This is where the spooky connection gets even stranger. On the cutting edge of theoretical physics, a radical concept is emerging: the quantum engine. This isn't a propulsion drive that creates motion. It's an engine that creates power by harvesting it from the seemingly empty vacuum of space itself. The theory suggests that two entangled particles, or oscillators, can be used to pull real energy out of the quantum fluctuations of the void. By carefully measuring one of the entangled particles, you can influence its twin in such a way that it extracts a tiny but real amount of energy from its surroundings. The amount of energy is minuscule for now, not nearly enough to power a city, let alone a starship. But the principle is revolutionary. It suggests that an interstellar probe, equipped with a quantum engine, could sip on the energy of empty space to power its systems indefinitely. It wouldn't need fuel. It would draw its lifeblood from the very fabric of space-time. It would be a truly immortal Voyager, a ghost ship powered by a ghostly connection guaranteed to be functional when it arrives at its destination, no matter how many millennia the journey takes. So where does this leave us? Quantum entanglement, this spooky action at a distance, is not the shortcut to the stars that we once dreamed of. It does not break the universe's ultimate speed limit, the speed of light. Einstein's ghost can rest easy, but it offers something just as profound. It offers us the tools for endurance and security. It gives us the ability to have a private, unbreakable conversation across light years and a way to power our lonely Voyagers for eons. It doesn't allow us to cheat the rules of the cosmos, but it provides a new and deeper way to follow them. The spooky connection that binds two particles across the universe may one day be the very thing that allows humanity to finally leave its cradle and establish a lasting, connected presence among the stars.